Hey, what's happening guys? In this tutorial, we'll continue on learning more about NumPy. Actually, I was supposed to cover more topics that I wish I had covered in the first video, but let's keep continuing. Alright, so this is NumPy Basics 2. As usual, the code is available in the description, and here we go. So import NumPy as np. That's the first step. So let's start by creating a NumPy array. So I'm going to say a equals np.arange, which is something that we already explored in the last video, but I'm going to show you something that I have not shown you in the previous video. You can actually have a start, a stop, and a step argument. What is this? So let's say my starting point is 5, my stopping point is 15, and my step size is going to be just 1, let's say 2. So what is this? Now if I try to execute this and try to look at A, so it kind of produces this list, which is 5, 7, 9, 11, 13. So what is this basically doing? We saw arrange. Arrange is going to just put the numbers from starting till the stop argument. But this is called as a step size argument, which is basically going to say, hey, you want to go from 5 to 15 in what steps? In steps of 2. That's what it means. So in steps of 2, in the sense it's going to go from 5. 5 plus 2 is 7, 7 plus 2 is 9, so on and so forth. Now I'll give you another example really quick. I'm going to say b is equal to np.range. Again, start from 19, go all the way up till 33 in steps of let's say 3 this time. Okay, now if I try to print b on my screen, so here we have 19, 22, 25, 28, 31. And you see 33 is not included. I mean, so we did not go beyond 31. Why? Because if we have to go beyond 31, the next number should be plus 3, which is 34. And we don't have a 34, we don't have 34 in the limits. So therefore, the next number is not included here. Okay, I hope it makes sense to you guys. Alright, so that is np.arange with step size argument included. Okay, now what I want to show you is np.rand.random. Now what is this rand.random is going to do? It's going to actually basically throw out integers. So if I say, let's say 2 comma 3, now what is going to happen is it's going to say, it is np.rand.random. well, np.random.random, sorry. So it's supposed to be this. Yeah, so this is how we kind of produce a matrix with a specified dimension inclusive of random numbers. You see, np.random.rand is going to actually display a random number for a given dimension. Now if you try to look at the documentation, what this does is the dimensions of a returned array should all be positive. If no argument is given, a single Python float is returned. Alright, so this is the basic idea of np.random.rand. Let's make it 12 by 13, then we'll have 12 rows and 13 columns. That's the whole gist of np.random. You see, this is 12 rows with 13 columns. 1, 2, 3, 4, 5. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You see, like this, if we count, we have 12 such sets of 13 numbers, and that is np.random.rand. All right. The next thing that I want to discuss is np.arange. Well, what I'm going to do is I'm going to say np.arange. I already have np.arange. I'm going to use this alone. Okay, so I have array A, right? Let's say I want to include a number to this array. How do I do that? the way I do that is I'm going to say np.append, and if we look at the documentation, it says choose the name of the array and the values, and also choose the axis along which it gets added up. So let's not worry about axis at this point. Let's look at these two arguments. We have to pass in an array, and we also have to pass in a value that needs to be added. To which array do I want to append? I want to append to array A. So I'm going to say A, and what values do I want to pass? Meaning, what values do I want to add? I want to add, let's say 19, just for the sake of understanding. So I'm going to say A equals np.append, and I'm going to try to print A here, and you see 19 got added up. So this is one thing you have to understand. If you want to append an element, you can basically say np.append and then pass the argument along with the value that needs to get appended. Likewise, I could actually also pass values as well. It's not just one value. I could also append an array like of value. So I could say again A equals, I'm going to copy this just for the sake of saving some time, and I'm going to also append this time. I can actually pass in a list 3, 55, 34, 53, 553, and if I try to run, you see all these new values got added in addition to 19 that was previously added. So that is np.append. So just in case ever if you run into a point where you want to add values to the NumPy array, all you do is np.append and then you pass in a list that contains your values. Okay, so that is np.append. Now what I want to also talk about is np. So I'm going to talk about np.difference. So if I look at np.difference, it's going to take in an array A as an argument, and n is the nth discrete difference along given axis. I'll explain that in a moment. So let's say I just pass in np.difference and then pass in a value A. So what is this doing is it's basically subtracting the next number with the previous number. So, or in other words, it's subtracting 5 from 7. So it is 7 minus 5. It's going to be 2. 9 minus 7, 2. 11 minus 9, 2. 13 minus 11, 2. 19 minus 3, 6. 3 minus 19, minus 16. 55 minus 3, 52. 34 minus 55, minus 21. 553 minus 34, 59. So that is how np.difference works. So you can also actually pass in another argument, which is basically the nth difference along a given axis. So for example, if I say n equals 2, it's going to compute the same thing twice. So let me demonstrate this well with 1 and 2. Okay. Yeah. So here we have n equals 1 and n equals 2. Basically what this does is it's going to do the same sort of subtraction from this array. That's all it does. So it is 2 minus 2, 0, 2 minus 2, 0, 2 minus 2, 0, 6 minus 2, 4, minus 16, minus 6, minus 22, likewise, so that is how n equals 2 works. And if I try to do this n equals 3, it's going to compute the difference along nth axis for 3 times. So that's it. So that is how this np.difference works. Alright, so let's go ahead and talk about np.verticalStack. So this is something that you have to actually watch. So let us look at this vertical stack. What is vertical stack? All this vertical stack does is that it's going to just stack elements on top of one another. So let's say 1, 2, 3, 4, 5, 6, and I also say 7, 8, 9. Okay, now if I do np.verticalStack, wait a second, let's see what's going on. What kind of arguments does vertical stack require? Whoops. Oh, it requires a tuple. Okay. Let's try to fix this thing really quick. What is going on? Oops. Ooh. Okay, so basically it was expecting a tuple and I was being stupid trying to pass in a list. That's all the whole gist of it was. So it's kind of trying to accept a tuple. Okay, so a tuple is this one. So you know what, let's try to make this little simple so you guys could actually kind of understand what's going on here. I'm going to put the cell up and I'm going to say A is this, and I'm also going to say B is this. I'm going to say C is 7, 8, 9. Okay, now all I'm going to do is I'm going to say A comma B comma C. Now let's see what's going to happen. Whoops. Yeah, so this vertical stack is going to accept a tuple argument, meaning it's going to be something looking like this, right? And it's going to return all the elements stacked on top of each other. I don't know if one another or each other is the right expression to talk, but however, you get the point. So this is stacked on top of, well, 4, 5, 6 is stacked on top of 7, 8, 9, and 1, 2, 3 is stacked on top of 4, 5, 6. So that is how np.vstack works. Now if I were to try to sort of change the order, you could expect what kind of output you would get. So if I say B comma A comma C, now you could expect that, okay, so B is stacked on top of A. Now you see, what is B? 4, 5, 6, which is stacked on top of A. So that is vertical stack. I also want to talk about np dot column stack. Okay, and I'm going to pass in again, this thing also requires you to pass in a tuple. To make things clear, I'm just going to pass in 2 arguments at this point for the tuple. Notice how this thing works. So it is stacking. I'm just passing A and B. Imagine there is no C at this point. I'm just passing A and B. Now as I pass A and B, all the elements we have are 1, 2, 3, 4, 5, 6. That's it. Now if I say column stack, it is going to stack along the columns. So meaning it is going to stack the first column along the first along the 2 elements. So it's going to be let's look at this now. So 1, 4 is going to be the first row. Forget the fact that there is no C, okay? And then 2 and 5 is going to be the second row, and 3 and 6 is going to be the third row. Okay, now if I were to pass the same C, okay, and we have C here. Now if I were to pass C, notice what's going to happen. 1, 4, 7 becomes the first row, 2, 5, 8 becomes the second row, 3, 6, 9, which is the third column, becomes the third row. So that is column stack. You're stacking along the columns. You see 1, 4, 7 is stacked, right, along the column. So that is why we have this term called column stack. So I hope you guys understood what is np.vstack, what is column stack, np.difference, what is rand, what is append. I also wanted to talk really quickly about slicing. Let's talk about slicing really quick. So if I were to try to see array A, it's going to have all these elements, right? Now I just want elements starting from 9 to 13, let's say. Okay, I only want these elements. Now what do I have to do? I can actually do something pretty cool called slicing. It's like slicing apart 9 inclusive all the way up until 13. So what is the index for 9. It is 0, 1 and 2. So start from index 2, go all the way up until this is 3, 4, and you should also pass 5. I'll tell you what's going on here. We got 9 and 13, right? So this is slicing. I'll explain this thing really quickly. Let's look at A here. Okay, what is going on here? Slicing is a process which is pretty cool because you'll be able to choose elements in a specified range from a list or an NumPy array, whatever it is. So now I want 9 to 13. So what I did, I chose 9 and I passed in the index to 9. So index to 9 is index number 2, 0, 1, let's count, 0, 1, 2. So 2 inclusive. I want all the elements from 9 until 13, right? So what is index of 13? If this is 2, this is 3, this is 4, right? Now if I just wanted to, if I just said 4, basically Python would go to a point where, well, let me show you this and then we'll talk. So what happened was Python just said, hey, I'm only going to give you index number 2 and 3 because that's all there is over here. So the point is the upper bound is not going to be included. So it's always like, it's kind of like, you know, it's like an n-1 analogy. Think about it like this. So you want elements from 0, let's say, up until 9. So what you do is you're going to say 0, 1, 2, and also you're going to say 3. But the third element at the third index is never going to be printed, but element until the third index is going to be printed, which is going to be 9. Let me just show it to you quickly. So I'm going to say starting from 0, go all the way up until 3. So now what's going to happen is element at index 3 is not going to be printed, but element at index 2 is going to be printed. So that is how it works. So in general, slicing analogy is you're going to pass in an array of inclusive all the way up until, or I can actually call this as, you know what, lower bound, and this is going to be inclusive, right? You're going to include this value. Oh my god, inclusive. Okay, and this is going to be the upper bound, and this value is not going to be included. That is going to be exclusive. So that is how this is the basic general formula for slicing. I mean, it kind of is a little funny, but once you get used to this slicing thing, you'll start loving it. So that is NumPy slicing. Let's just keep that thing commented. Okay, so let's continue, and I think I have to discuss about one very important thing called as broadcasting. So what is broadcasting? Okay, so now let's go back to our array A. This is a super amazing feature from NumPy, and the reason why it's so amazing is because of this. So let's say I want to do A plus 3, or let's make it just A plus 1. You see, this 1 is going to be added to all the elements. Internally what is happening is it's kind of like this: A plus 1 plus 1 plus 1 plus 1 plus 1 plus, how many elements do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this line alone here is equivalent to this line here. How do I know? Let's run and see. You see, it's exactly the same output. So the whole takeaway with broadcasting is if you just pass in one element to an array, when I say pass in, all I'm trying to say is trying to, if you just try to operate with one element of an array, all the elements of the array get added up. That's what this entire broadcasting is going to be in gist. So the whole idea behind broadcasting is that you don't have to explicitly write the array. Broadcasting is mostly good in most of the part, and it is bad sometimes. You cannot it's kind of like a two-sided coin. So let's say I have array B. Let's look at array B. Okay, now if I were to say A plus B, now it's throwing us an error. But what if I said A plus, or let's say for that matter, A star minus 1? That means multiply the entire array with minus 1. You see, every element of the array got multiplied by minus 1. That is something cool that we will look at this, especially when we kind of navigate with neural networks and such. But this is a really cool, handy tool that Numpy provides us. So that is the basic idea of broadcasting, and we'll talk about more topics about Numpy as we proceed further. But at this point, this is all there is. If you like this video, give it a thumbs up, subscribe and share, because I'm trying to sort of improve my productivity. I know I've been really slacking in these videos. My apologies. Well, I'm trying to get as quickly as possible the content out so you guys can actually really enjoy this video tutorial series. That's it. Thank you.